This is my favourite A-level maths question I've seen in a long time. It's a 6-marker and you really have to earn those marks. Now, we're given these two equations here, and given x and y appear in both, these are simultaneous equations. So start to think about how we might solve them. I'm going to call this one here 1 and the second one 2. And actually what I want to realise is that e to the x plus y, we can rewrite that. So I'm going to rewrite equation 1 as e to the x times by e to the y equals 6. Okay, because when I multiply these two things, I add the powers, so it's the same thing. I also want to rewrite 2, and all I'm going to do is just change the subject to e to the y. So let me make this e to the y equals, well, it's 5 minus our e to the x. Now you might realize, because we've made e to the y the subject, we can substitute it into 1. So we're going to sub 2 into 1. And when we do that, we get e to the x multiplied by e to the y, which you just said is 5 minus e to the x. And that equals, where do we look at? 6. Okay, that equals 6. Fine, let's expand these brackets. We get 5 times e to the x, so that is 5e to the x, minus e to the x times e to the x. I'm going to call that e to the x squared. So 5 minus e to the x all squared, because I've multiplied it by itself, equals 6. Now I'm going to leave it like this, okay? And what I'm going to do, bear with me here if you haven't spotted it already, I'm going to move everything to one side, okay? So I'm going to be left with 0 on this side. I'm going to add on e to the x squared. So I've got e to the x squared minus 5e to the x, so minus 5 lots of e to the x. And I've still got this 6 over here. Now, I'm hoping you spot, we actually have a hidden quadratic here, okay? To help you spot that, I'm not going to use y because that's somewhere else. I'm going to use n. So let n equal e to the x. Okay then, well, we've got e to the x, which is n. So I've got n squared minus 5e to the x, so minus 5n. Plus 6 equals 0, remember? And I've got a quadratic here. This is a hidden quadratic that I can solve. I can actually factorize, so I can say n minus 2 and n minus 3 equals 0. So n equals 2 or n equals 3. Now, we're not done. Please don't stop at this stage. Remember what this means. This means that e to the x, because n was e to the x, right? So e to the x equals 2 or e to the x equals 3. Now, I'm going to run out of space here, so let me move over here. So starting from here, we need to solve for x. So I'm going to write that back over here. E to the x equals 2 and e to the x equals 3. So we take logs of both sides. So for this solution here, take logs of both sides. Log of e to the x is just x. On this side, we have log 2. On this side, same thing. So x is going to be log 3. Now, we're still not done. This is why we have to really earn that 6 marks. We still need y. And the easiest thing to do is to substitute into one of these. I'm going to go for equation 2 is going to be a bit easier. Okay, so e to the x, well, that is e to the log 2 equals, plus e to the y. So plus e to the y equals 5. Okay, e to the log 2, that cancels. So that is 2 plus e to the y equals 5. Well, then e to the y equals 5 minus 2, that is 3. And just like before, take logs of both sides to get us y equals log 3. So for this solution, x is log 2, y is log 3. Similar logic here. I will show you the method though. When we substitute it in, so e to the x plus e to the y, that is e to the ln 3, so log 3, plus e to the y equals 5. Okay, these cancel, so we're left over here with 3 plus e to the y equals 5. Well then, e to the y equals 5 minus 3, that is 2. So y equals log of both sides, log of 2. That was a nice question, I think.